confirm that?
Yeah, I can see it.
Okay, cool. So we'll start with find pivot index. The question goes, given an array of integer nums, write a method that returns the pivot index of this array. Okay, so what is a pivot index? Pivot index is the index where the sum of numbers to the left of the index is equal to the sum of the numbers to the right of the index. If no such index exists, we should return -1. If there are multiple pivot indexes, then you should return the leftmost pivot index. So for example, they have given a nums array, which is in the form 173656. Okay, and if we and the output is 3 because that's the index. So if you look at 0, 1, 2, 3, if the pointer is at number 6, which is at the third index, the sum of the numbers to the left of that index, which is 1 plus 7 plus 3 is 11, and the sum of the numbers to the right of that index, which is 6 plus 5, is also 11. So you return the index and not the number, okay? And yeah, that is the question. And they also want us, if there are multiple such indexes, then you have to return the leftmost index, okay? So the second example that they have over here is with numbers 1, 2, 3. And since none of the index has it, the sum of left to the sum of right, the output is -1. Also, something to consider is you don't calculate the sum of the index, that the pivot index. The number is not counted in the sum. So this is the problem. Has anyone solved it?
Yeah, I solved this problem. So basically what I did is, so I first took a sum of all the elements in the array,
Mm-hmm.
right?
Right.
And okay. And then what I did was, like, I made a variable to keep track of the sum, which is of the left side of the current element that I'm checking. So I
Okay.
initialized the left sum variable with 0.
Mm-hmm.
And then, so basically for the 0th index, the left sum is 0, and we consider whatever the sum is on the right sum. So what would be the right sum of the 0th element is, like, we'll subtract this element from the total sum of that we have already computed. So then I'll get what is the sum on the right side, and
Mm-hmm.
I've already initialized the left sum variable with 0. So
Right.
so I'll go in order. So even if there are multiple instances,
Mm-hmm.
whenever I find the first instance when this condition satisfies that left sum is equal to my the right sum that I've calculated is like total sum minus this current element.
Okay.
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 And then what I do is, after this iteration, what I'll do is I'll subtract the current element from the total sum,
Mm-hmm.
because after that it won't take part in the right sum element, right? So then I'll update the total sum is equal to total sum minus the current element, and I'll add the current element in the left sum. So I'll know at each instance when I check for every index, I'll know what is the sum on my left hand side, and I can easily find the right sum with my updated total sum minus the current index. So whenever at first I find this to be equal, I'll just return the index.
Yeah. I kind of followed the similar approach. What is the time complexity of the problem that you solve?
So what I'll do is I'll need to like calculate the total sum of the array, which is an O of n operation,
Mm-hmm.
and then for every like element I'll need to check whether this is satisfied or not. So that would be an O of n operation. But because I'm calculating all the sums in a constant time, so it's just at worst case I'll need to check for every element if the let sum is equal to the right sum or not.
So it will be O of n
Yeah,
then, or a
yeah,
constant to n?
yeah. It will be O of n because I'm actually pre-computing the total sum, and I'm iterating, like checking each element at most once I'm touching, because I'm updating my sum variables in constant time.
Okay. And no extra space used, right?
Yeah, it's constant space. It's constant space.
Okay. Okay. Any other approaches, as if anyone has attempted? No one? Okay, I think even I solved in the same approach pretty much. So um, should we move on to the next problem? Any questions on this approach? Okay, since I don't hear any.
Maybe I was suggest a variation of this problem.
Uh-huh.
Like if the problem says that the numbers are not negative, then can you do it in one pass?
Can you repeat the question, Roger?
Sure. So the question is that numbers are not negative, for example.
Okay.
Then do you need to do two passes in that case or not?
If the numbers are not negative, then what is the question? Sorry, I couldn't hear you clearly.
Sorry. So
Okay.
numbers are not negative.
Uh-huh.
Currently we are doing two passes, right? We
Right.
first calculate the sum and then we go to each index and find the left and the right, whatever. Based on that sum, we can separate that.
Right.
Suppose the question gives you, okay, that number is not negative, all numbers are positive or greater than zero.
Mm-hmm.
Then can you do one pass solution?
Oh,
Same
okay.
problem.
Okay. Hmm. So I'll just repeat the question that Roger asked. Like, if the numbers are all positive, greater than zero, then can we do, since we're doing two passes, one to calculate sum and then actually going through each numbers, can we do the same problem in one pass if the numbers are all positive? Hmm. I'm thinking. Roger, I guess you know the solution to the question you are asking.
Who knows the solution? Sorry, I don't know the solution. I just asked.
Oh, okay. Okay.
Yeah. So like,
Can we think in terms of binary search? If we have the cumulative sum array, can we think in terms of binary search?
But the array is not sorted,
Well,
so we can't do binary search.
So I don't need a sorted array. A sorted array will be a cumulative sum array, right? I don't need to
Yeah.
work on the original array. If I have a cumulative sum array, that will be sorted.
Okay.
So essentially your operations in this program, if all the numbers are positive, are not on the actual elements. They are on the sum of elements, right?
mm-hmm.
So if we have a cumulative sum, it's an increasing array. So if you choose a pivot and what you have to see is left side sum and right side sum. If left side sum is greater than right side sum, definitely you have to move to the right side. Right, to increase the, sorry, you have to move to the left side to increase the size of the right side so that the sum becomes equal or closer to equal. And if you reach a point where you can find the sum of left segment and right segment equal, that's your answer.
The problem that I see with this is like, if there are multiple instances of the pivot, so if you find it on the midpoint, but there also exists a like point on the left part of the site, so how do you handle
How will you
that?
find How will you find multiple pivots? Can you give me an example where you have multiple pivots?
The elements are
If,
zero
if
after a point. Elements are zero after a point. So
that's
you
what
can
the
always.
condition, if you have
Huh?
all elements greater than 0, that's what the initial statement was.
Okay. I thought only positive. He
Even if
said positive.
even if you have some zeros, that doesn't matter. You'll reach one point where you will have equal, right? You don't need to find all the pivots. You need to find one pivot.
But we need to find the leftmost pivot, I guess. So, like
If it
if
means, Mhm. And okay, so in case of leftmost pivot, it will be similar to having the floor of problem seal of the problem. So you have to find the element which is less than or equal to the current element which you have to find. Maximum element which you have to find. So you can find the floor and seal of an element, right? So
yeah.
essentially what you are doing is you find the pivot element, right? Consider the third index is the pivot element. You take it as a potential candidate in your memory. And if you have way to go to the left side, go again to the left side. And if that fails, that means this is the leftmost, right?
Yeah.
So that is usually how you find the seal and floor of a number in the case, right? So if you have 333 and you're asked to find the seal of a number, so it essentially goes out of all those 3 repeatings and then finds a number.
Even if you do the binary search, that's not a single path, right? Because every index you find, you have to search, you have to find the sum on the left and the sum on the right. So that's not a single path.
All right, you're right.
Yeah, so I was expecting can you use 2 pointers for this, like start with left and right, just traverse. If left is smaller than right, keep adding left index, and if right is smaller than, traverse in the opposite direction as soon as they match. I haven't solved it, so I'm not sure, but I think that should work in one pass if it works.
But it'll again be O of n. I don't think we can do it faster than that.
No, it's O of n. We were thinking of one pass solution. We can't make it better than O of n, I guess, right?
Right.
Yeah, even with cumulative sum, we have to add all the elements. So,
Correct.
yeah. Go ahead. Yeah, that was just a question which come while I was listening to this.
So with binary search, we still can do in single path, right? Because
Right.
if we keep track of the previous pivot that we use, right, and we already know that sum, then potentially we could do in single path. So because let's say you pick the pivot in the middle and you know what would be the sum on the right, right? Now you need to move to the left and you only need to compute the delta difference between the previous pivot and the new mid index.
Is there a question here?
Question, yeah. Thanks.
So I don't know, like if you are thinking about binary search, then you have to find a monotonically increasing or decreasing function. But to generate that, you have to waste one pass already, right? Because and then you are already using that one pass, and then you can do binary search. That is okay, but you are not doing one pass solution. I mean, the problem I was specifically asking, can we do it in one pass? And that's why I was thinking about a 2-pointer approach. Sounds good? Or is there a question on that?
Yeah.
Okay. We can move ahead. Like I think it should work, but I am not in front of a laptop to confirm. But
Even in three-pointer approach, I'm not sure how that will work. So if you have suppose,
then yeah, just put one example. We can walk through this in real time. It shouldn't take
yeah,
too long.
today I'm not on my laptop, so I cannot share.
You want
We can, yeah, with the same example we can put, and let's try that.
you want me to use whiteboard?
Whiteboard is okay, or you can go through this first example and see if we can find the solution.
I lost you, Roger. Can you repeat that? Sorry.
Yeah, try to go through this first example
Uh-huh.
and try two pointer and see if we can find a solution. Like that's the
Using
easiest we
two
can do.
pointer.
Yeah, first example. Yeah.
Probably I can just try it here. Right. And so let's say our I is at 0th index. So I is starting at 0, and the second pointer is starting at the end of the array. Is that correct?
Yes. Yes. Yes.
I'm just going to put and we are calculating sum throughout.
Yeah. So left sum is 1 and
Yeah.
right sum is 6 to begin with, right?
Yes.
So let's increase the left one.
Right. 6, and then you increase the left sum to 1 plus 7, that is 8,
Right.
and the sum of right would be 11. 6 plus 5, 11,
So now increase the left one.
and the left one goes 8 plus 3, 11. And so when do you move the right pointer? What is the condition?
So at this point of time, the distance between them is what? 1, right?
So I was at 3.
So we have a, like, we are standing at a point where, like, everything towards left has been calculated and right. So you have that. But the question is, what if, like, there were a couple of more items, right? In between.
Right.
So what decision we can take in that? I would suggest move in that case right pointer, because we are planning to get a solution where we want the leftmost solution, right, out of all the possible solutions.
That's correct.
So we will take that decision,
Mm-hmm.
and then hopefully if there is a solution, we should be able to get it.
Yeah, I think if we code this, we might.
Sure. If
Yeah.
I get time, I will code it for that particular.
Yeah. I think that makes sense.
Cool.
Okay.
Thanks.
Cool. Thank you, Roger.
Thank you.
Should we move on to the next question? Does anyone have any questions? Okay.
One thing I just want to mention one thing. I just understand the question now, and I just come up with the Roger approach, which he explained in one of the last question, taking two arrays, taking some from the left and taking some from the right, and then whatever the index, and then check if there is some which is matched left to right, left and right, take that particular index. Like what earlier he mentioned, like taking some from left to right, and then similarly reverse the array, like reversing the sum from the right side, and then taking another array and putting that, like filling the values from the right side, and then just check where there's some match left, and that would be our answer. That would be the index.
Yes,
But
Sonia, that is a good solution. Yeah.
That would be an extra memory.
So,
the only thing is, if you can relate that approach That's what I related, which Roger explained once before. Yeah.
Yeah, it was in a different session, so you may not understand what she's talking about. Like,
Yeah, but
yeah.
Roger, can you understand that it
Yeah.
can be solved with that approach
Yeah,
also?
yeah, that was my first approach, because anything comes like that, I start with that and then try to optimize the space.
Yeah, that's correct. And thank you for so much for explaining. And I just relate that approach over here.
Great. Yeah.
Cool. That's great. So you are using extra space, and is it, Sonia?
Yeah, it's an extra space, but it would be in order of n. But
Okay.
yeah, extra space.
But then that will be just one pass.
Yeah, no, it will be in two pass because you have to go to left to right and then right to left.
Okay, cool. Okay, that's an interesting approach to using two-pointer. Okay, so we had like 3 approaches in which this problem could be solved. Should we move on to the next sum?